This is temp. Oh no, error. Oh, phew, not error. We did all this. This is a quick review. Oh no, error. I should just restart this video, but I'm not going to for your entertainment. Alright. So last time we were talking about doing significance tests and interval testing when looking at the difference of two proportions as opposed to, oh, fun fact, I went too far. Holy smokes, went way too far. Alright, so let's look at forming a confidence interval for a difference in proportions, y'all. So, formula remains the same to what we're used to. Hiya, hiya, highlighter, hiya. So for this one, we have our mean, which is just the difference in our proportions, plus or minus our z, our critical value, times our standard deviation. We know this from chapter 8, guys. It's all a review. Now we're going to use z. Remember your 1.96 for 95%, right? Your 2.5 for 6. So these are going to be the same values we know in 1.6 for 5. Okay, or we can use our table to find them out, or we can do inverse norm. Okay, if you'd like to learn more, go back and watch the videos in chapter 8 on confidence intervals. And now all I'm concerned with is the things that are changing is my standard deviation and my mean. Okay, so let's do one. So we're going to take a random sample, a randomized comparative experiment. We're going to take two groups, and we're going to find the difference between them. All right? This guy, he's in so much pain. He's like, oh, my back, it's broken. Been from carrying this school for so long. All right, so patients are usually given NSAIDs, aka non-steroidal anti-inflammatory drugs like ibuprofen, to help with pain relief. They got 112 patients with back pain and assigned two of them, or one group, naproxen and Valium, and the other one, naproxen and placebo. After 1 week, 37 of 39 patients who took both had reduced lower back pain, and 43 of the 55 in the other group had pain. So let's make a confidence interval about the difference in proportion in back pain between the two groups. So first thing we're going to do is check our conditions, or state. We're making a 99% confidence interval for P1 minus P2, where P1 is the true proportion of patients who reported reduced lower back pain using 2 meds, and P2 is the ones who had reduction in lower back pain with just the 1 med. Okay. Plan, now we're going to check our conditions. This is now a 2-sample test. It's a 2-sample test because we're taking 2 samples. We randomly assigned who got treatment, and large counts is successful as our n times p and our n times 1 minus p. Are both successful. This is math. Bonkers. Yeah. Push the button. Why am I tapping the screen? I don't know what I'm doing. Alright, now time for the do. So one of the first things I'm going to do is find my proportion of each, right? So P1 and P2, right? So P2 goes here, P2 goes here, P1 goes here, P1 goes here, right? So, so my proportion of the first group I put in for my P1, proportion of my second group I put in for P2. I'm going to add or subtract. Now since I'm 99% confident, that's where that 2.576 comes from. That comes from the 99% confidence, right? 0.99, use your table or have it memorized 2.576. And here's my standard deviation of this one plus my standard deviation of this one. Now we're actually using our statistic data, not our null, because we don't really have a null. We're doing a confidence interval, right? So I do my calculations, I get this, and my confidence interval is from negative 0.312 to 0.116. So it's plausible that 0 is the difference. Uh-oh, that means there might not be a difference. So let's conclude. So we are 99% confident that the interval from blank to blank captures the difference in the true proportions of patients between the 2 drugs and the 1 drug for 1 week. Now, I'll go back and pause it if you need it, if you love it. Again, we've done all this before. The only thing that's changing is our formula slightly. So based on this confidence interval, can we make a conclusion that there's a difference? No, because 0 is plausible. That doesn't mean there isn't a difference. It just means it's plausible that 0 is the difference, so we can't draw a conclusion based on it. Da-da, bah, 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 bah. It's just plausible that's 0. Doesn't mean it is 0. Now I come with good news. Majority of the time, you're actually going to find these on your calculator and not do them out longhand. And that's okay. You're going to go and use your 2, because there's 2 sample, dash prop z interval. Z because it's proportion, 2 because there's 2 samples, and then you plug in your x1, your n1, your x2, and your n2. We had 39 out of 57, 43 out of 55. You put in your confidence level, you hit calculate, and look at that. We would have gotten the same answer. And it'll tell you the P1 and the P2. So make sure if you're doing it on the AP test, you denote that you're doing this on your calculator, or obtained from calculator. Please. You can try this in class with your calculator. Now let's do a significance test. So this is different than a confidence interval, right? So we're going to make a null hypothesis. Our null hypothesis is going to be that there's no difference between P1 and P2. So when you subtract them, it's 0. And we're trying to show that there is a difference. Okay? Again, we're checking our conditions just like before. I'm not going to spend a lot of time on this. Just make sure you check all 4 conditions again. 4 for large counts. N times P, N1 times P1, N1 times 1 minus P1, N2 times P2. You have to check 4 of these. Everything, and you have to check 2 up here. Everything you have to check everything twice. Right? I'm sorry I'm not spending a lot of time on this, but again, this is a lot of review. Go back and watch Chapter 9 videos if you'd like to see in more detail. So, kids coming to school, not eating their breakfast. Is there a difference? So, we think that it's going to be different between these 2 schools. So, one found 19 out of 80 missed breakfast, and in a different school, 26 out of 150 missed breakfast. And more than 1,500 schools attend those schools each day. Does this give significance data that there's a difference in the populations at 0.05 significance level? All right. So let's state our null hypothesis. Our null hypothesis is P1 minus P2 is 0. We're going to assume there is no difference. Okay. And then our alternative is it's not equal to 0, so there is a difference. One's bigger or one's smaller. It's going to be a 2-tailed test. Okay? Because we don't know if one's bigger or one's smaller. We aren't assuming that. We're just going to try to find out if they're not equal. And then don't forget, this is what my P's mean. So P1 is going to be school 1, P2 is going to be school 2. All right. Sorry I'm going really fast, guys. Most of you guys probably watch this at double speed anyways. Why is this not working? All right. So let's check the conditions. Is it random? Yes, random sample from school 1 and school 2. Is it 10%? 80 and 150 are both less than 10%, or less than or equal to 10% of the schools. Large counts passes when you go through and do it each way. Okay, so we good. We are good. Again, our standardized test statistic is statistic minus parameter over standard deviation. Chapter 9 to learn more. This is what the dirty formula looks like. Look at that. Because standard deviation formula changes, right? We're using the one that we learned from Part A. Mean is just going to be the P1 minus P2, not the mean proportion. Now, remember, in this one we're using P1 and P2. Okay, so be careful. Be careful. Alright. So how do we find our P for this one? This is actually where things get really tricky for significance tests. What we're actually going to do in order to find the P for our sample on this one is different than the confidence interval. What we're going to do is we're going to combine the data and make one proportion that's both pieces of data combined. Then we're going to use that P to find our standard deviation of the sample. Alright? So much to memorize and so different. We're going to use our calculator for this most time. Okay? So here's our data from school 1 and 2. I'll go down here. Alright. What's the first piece of evidence we have that they're different? Well, P1 minus P2 is 0.062, so there is a difference. It's not 0, so that's some evidence that they're going to be different. But are we statistically sure? Let's find their test statistic. So, for this we need to find, this is our combined. We're taking the data from both schools, we're combining it to find the proportion total. And that's what we're going to use to find standard deviation below. Okay. Then up here's the difference between the two schools. And we find out Z is 1.17. Alright, so then we're going to use table A, or using our calculator. And we could use our calculator right away with our standard deviation mean before. But I'm going to show you another way. So this is table A way, using our test statistic to find P. This is one way to use calculator. The other way we could have done it is we could have went the difference in the means to 99999 with our mean of 0 and standard deviation found from before. I'll show you guys that in class. I'm not going to spend a lot of time on it now because we're going to mostly do the calculator way for these and interpret. See, what conclusion can I make? Because our p-value is much larger than alpha, we failed to reject null. There's not convincing evidence that there's a difference between the two schools in proportion of students who don't eat breakfast. Now let's say I was using a calculator. I would do a two sample prop Z test. Okay, it's a Z significance test. And I plug in my x1, same things I did before. And I put in my not equal to for my null. And again, it'll give me Z, it'll give me P, it'll give me all the data. It's beautiful. You gotta learn how to do this in your calculator. Okay, guys. And be careful. Make sure you name the procedures in your plan. Make sure you tell them what you're doing. All right. Make sure you still state your Z and your P values in the plan step. All right, or else they will not be happy with you if you're using a calculator. Again, here's that magic formula where P hat is, remember, the combined. I'm actually going to save this one for class. I'm going to save it. I'm going to save it. I want to save it. I want to save it. I want to save it. Because I want to do one with you guys together. So have a great day. You're done. Enjoy. Ta-da! Ta-da!